How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 15.4, heterogeneous equilibrium. So our objectives will be to accurately set up the equilibrium constant expression and calculate its value for heterogeneous equilibrium, including saturated solutions. Look at that. All right, so hetero means different. Genius is talking about its composition. So we're talking about when we have a mixture of, like, let's say solids and things that have dissolved. We have a heterogeneous equilibrium because we have compounds that are in different states. And basically what happens, the takeaway is solids, you don't use in the KEQ. Same thing with pure liquids. You don't use them in the KEQ. And the reason for that is, if you remember what happens to the units, well, they get compared to a standard, a reference. So if we're talking about aqueous things, the reference is 1 molar. And if we're talking about pure solids, their reference is the concentration of a solid. So it just cancels itself out. And same thing with the liquid. So we don't include them in our equilibrium constant expressions. All right, so number 1, the equilibrium constant expression does not include pure blank or pure blank. So you could change the order, pure solids or pure liquids. They are not included in the equilibrium constant expression. So number 2, what is the correct equilibrium constant expression for this equilibrium? So again, hey, wait a minute, here's a solid, so I'm not going to include CO2, solid. Hey, H2O liquid, not going to include that. All right, we got aqueous, those are going to be included. So I'm going to go, hey, my KEQ is going to equal the concentration of my products. So I got H plus times HCO3 minus divided by the concentrations of my reactants, which, hey, I have no reactants that I'm including, so this is it. That's it. All right, number 3, the Kp for the reaction that follows is blank. So again, hey, wait a minute. Here's a pure solid. It's not going to be included. Let's see, gas, that will be. Gas will be. Ooh, pure solid, not going to be included. H2O gas will be. All right, so my Kp is going to be the pressure of my products. So I look, hey, I got CO2 as one of my products. I have H2O as one of my products. And that H2O is going to get squared because the coefficient in front of it is a 2, divided by the pressure of my reactants. So I got, let's see, CH4 with a coefficient of 1 times the pressure of, oh, wait, that's the only reactant. There you go. So that's it. That's my Kp. Boom. All right, last one for this section. What is the Kc for PbF2, given that 1.5 times 10 to the minus 3 moles will dissolve in 1 liter of solution? So let me start with the Kc expression. So I go, hey, my equilibrium constant in terms of concentration. Well, let's see. PbF2 is a solid, not going to be included. Pb plus 2 is aqueous, will be. F minus is aqueous, it will be. So, all right, concentration of my products, Pb plus 2 times F minus, which is going to get squared, divided by my reactants. There's no reactants that I'm including, so this is it. So now it wants to know what is the value for this. So I got to figure out, well, what is the concentration of my Pb plus 2 ion going to be? What is the concentration of my F minus ion going to be? Well, if I'm dissolving 1.5 times 10 to the minus 3 PbF2, well, for every time I do that, I get 1 Pb plus 2. So, oh, it's nice. They said in 1 liter solution, so I know this many moles per the 1 liter is the molarity. So the concentration of this Pb plus 2 is going to be 1.5 times 10 to the minus 3 molar. And then I get 2 fluoride ions. So the concentration of the fluoride ion is going to be twice as much as my lead ion. For every one of these I dissolve, I get 2 fluorides. So the concentration of that is actually going to be 3.0 times 10 to the minus 3. I doubled it. So now I can plug those values in. I go, all right, the concentration of Pb plus 2 is 1.5 times 10 to the minus 3 times 3.0 times 10 to the minus 3, which is going to get squared, right? Because we got that 2, it gets squared. So now I can just plug and chug, beep, bop, boop, and I end up with 1.35 times 10 to the minus 8 as the value. All right. Hope you found that helpful. See you in class. Okay, bye.